Hello everyone. In today's session, we'll be learning about different multiply instructions available in ARM. Okay, and the very first instruction that we see is the most simplest of all, MUL R3, R1, R2. And as you can expect here, content of R1 is multiplied with content of R2, and the result, that is the product of the two, is stored in the register R3. Okay, now if you notice here, in the previous instruction here, we have stored R1 as 10 and R2 as 4. So the result 40 is supposed to be stored in R3. Okay, but because we'll be storing the result in the form of hexadecimal format, the decimal 40 is converted to 28 in hexadecimal, and that is what you can see in the register window. Okay, and since we have not used yes after mul, any updation of the conditional flags won't be happening. If you want to see any changes happening in the CPSR, that is conditional flags, make sure that you use mul s. Okay, or any instruction that we'll be discussing now, after those instructions use a suffix yes to update the conditional flags. But because I have already explained about that, I have not used it in the next set of instruction. Okay, next we have the instruction MLA, which is multiply and accumulate. What happens here is this register content R3 is multiplied with R1 and the result generated is added with R2. Okay, it's R3 into R1 plus R2. Okay, and the result of that is stored in the register R4. Okay, hence it is called multiply and accumulate. In our case, R3 is 3, R1 is 10, 3 into 10 is 30 plus 4. Okay, 34 is the decimal value. Let's see what answer is stored in hexadecimal. The answer should be 22. Okay, so that's the answer we see in R4. Fine. So here we have instruction called LDR R2 comma equal to something. This is a pseudo instruction. Whenever we want to take a large value which cannot be taken using the move instruction, then we use LDR register name followed by equal to and the desired number. And this instruction is called pseudo instruction because this value is not directly copied to the given register. Like for example, this will not be directly copied to R2. Instead, this data will be stored in the memory location. Whenever you run this particular code, that data is copied from the memory and placed for the required operation. Okay, if you are using LDR, you can load any arbitrary 32-bit value regardless of bit pattern. But when it comes to move instruction, only specific bit patterns are allowed. Okay, so the very first value we are loading into R2, whose decimal number is 65,538, and the second value is loaded into R3. Fine. Now we are performing unsigned multiply long. Okay, so what is unsigned multiply long? Here we are considering that multiplication of the two register which is happening is nothing but an unsigned multiplication. We are not considering any signed values, but at the same time, the result of that, now we know R2, R3 are nothing but 32-bit register. The result of that can exceed the 32-bit. Okay, so the result generated for this particular multiplication could reach up to 64 bits of values. Okay, because of which we need two registers to hold the result. Okay, if you notice here, out of the total 64 bit, the higher 32 bit is stored in the register R1, the lower 32 bit is stored in the register R0. That's why it is shown here, higher value in R1 and lower value in R0. Okay, when you multiply R2 and R3. Okay, so this is one of the instruction. Fine. So the result of unsigned multiply long is stored in R0 and R1. As you can see, the lower 32 bits are stored in R0 and higher 32 bits are stored in R1. Then we have one more instruction called unsigned multiply accumulate long. Okay, so here what will happen is, okay, and in this particular case what we are doing is we are multiplying R2 with R3, and the result of that we are adding with the content already stored in R0 and R1. R0, R1 actually forms a 64-bit data. We are adding the 64-bit data to the result generated here from R2 and R3. Okay, and the final result which is generated is again stored in R1 and R0 in such a way that the higher 32 bits are stored in R1, lower 32 bit in R0. Instructions work similar to move instruction, just that if you want to be able to take any bit pattern, okay, if you don't want any doubt that whether I can load any value using move or not, then in that particular case you can use LDR, because in LDR you can load any 32-bit value into the respective register. So here we are loading all the required values into R0, R1, R2, R3, and we are performing the required unsigned multiply accumulate long. The result of unsigned multiply accumulate long is stored in register R0 and R1. The higher 32 bits will be stored in R1 and lower 32 bits in R0. Okay. In the next case, what we are doing is we are again taking two values in R2 and R3, but the multiplication we are seeing next is a signed multiplication, and the full form for this would be signed multiply long. So here what we are doing is we are multiplying R2 and R3, and the result, which could actually exceed 32-bit, and the result could be up to 64-bit, is stored in the two register R1 and R0. The difference between UMULL and SMULL is here the contents considered in the register are unsigned, while in signed multiplication or signed multiply long, we will be considering signed values in R2 and R3, whose result is stored in R0 and R1. Okay, let's see how that works. The result of signed multiply long is stored in register R0, R1, lower 32 bits in R0 and higher 32 bits in R1. Okay. Next, we are taking new values here for R0, R1, R2, R3, and we want to perform here signed multiply accumulate long. So here what should happen? Signed numbers are multiplied, and that product is to be added with the content already stored in R0 and R1. Okay, and the final result generated is again stored back in the register R0 and R1. Let's see what result we obtain for that. If you see here, this together forms the result of signed multiply um, accumulate long, where this R1 content is the higher data bits and R0 forms the lower data bits. Okay, higher 32 bit is stored in R1 and lower 32 bit is stored in R0. These are some of the multiply instructions available in ARM. Okay.